All right, let's dive in to one of the biggest, most fascinating shifts happening in tech right now. We're talking about the huge leap from the artificial intelligence we have today to something called artificial general intelligence, or AGI. And look, this isn't just some minor update. It's a total rupture, a fundamental break in how we even think about building a mind. But to really get a handle on this rupture, first we've got to understand the paradox that's sitting right at the heart of today's AI.
So, before we can even dream about where we're going, we need to get real about the very strange place we're in right now. And a lot of people are calling it the AI paradox.
I mean, just look at this. It really sums up the whole contradiction perfectly. On one hand, AI has these incredible, almost godlike skills. It can write code, it can dominate the world's best chess players, it can create breathtaking art. But then, on the other hand, it has these almost childlike failures. It trips up on the most basic reasoning. It doesn't get cause and effect, and if you change the rules on it, even in a simple game, it's totally lost. So what's the deal? How can one thing be so brilliant and so clueless, all at the same time?
Well, the answer is that the way we're building AI right now is hitting a fundamental wall. And it's a wall that's built right into the very design of these systems.
At the absolute core of the problem is this idea, stochastic mimicry. Now, it sounds complicated, I know, but you can really just think of it as glorified autocomplete. Today's AI is ridiculously good at predicting the next word in a sentence based on the mountains of text it's been fed. But that's all it is, mimicking patterns. There's no real understanding of the world behind those words. It's like a parrot that can recite Shakespeare perfectly but has no clue what any of it actually means.
And that leads us straight into what's called the static trap. See, today's AI models are basically frozen in time. They do all their learning in one giant batch, what engineers call design time, but once that's done and they're out in the world, they can't learn new things on the fly. They're just a snapshot of the data they were trained on, totally unable to adapt or update their knowledge like you and I do every single day. And here's the real kicker. If you even try to teach one of these frozen models something new, you run smack into catastrophic forgetting. The very act of learning the new thing can completely wipe out and destroy the old information. Seriously, it's like trying to add a new chapter to a book by first erasing all the ones that came before it. For years, the main idea in the field, known as the bitter lesson, was basically that we could just brute force our way past these problems. Just throw more data and more computing power at it, and eventually we'd get there. But now, a lot of experts are saying, nope, we're hitting a wall. We're just getting diminishing returns. Turns out, just making an encyclopedia bigger and bigger doesn't magically turn it into a scientist who can think for themselves. So, getting past this wall isn't about just making a better version of what we already have. It's going to take a major pivot. We have to completely redefine what we even mean when we say the word intelligence. And this right here, this is the absolute core of that shift. The goal is moving away from what's called crystallized knowledge, which is basically just what you know, the facts you've memorized, and moving toward fluid intelligence. And that's all about how you adapt, how well you can solve problems you've never ever seen before. I absolutely love this way of putting it. The old goal was like building a specialized toolbox, right? You've got a different specific tool for every single problem. The new goal? It's about building an all-purpose compass. A compass doesn't give you all the answers, but it gives you the power to find your way through any new, unknown territory you stumble into. And of course, if you change the goal, you've got to change how you keep score. The way we test for AI intelligence is changing completely. We're moving away from old benchmarks that are basically just glorified memorization tests, like passing the bar exam. Instead, we're moving to tests of pure adaptation, like these things called ARC puzzles, which challenge a system to figure out brand new problems from just a few examples. And by the way, current AI is just awful at these. Okay, so if the old architecture has hit a wall and the new goal is this fluid, adaptive intelligence, then what in the world is the blueprint for a new kind of mind? Well, the whole field is now shifting its focus to creating what they call cognitive architectures. One of the most popular ideas out there is this concept of a dual-loop mind. You can think of it as a hybrid system. It has a system 1, which is fast, intuitive, all about pattern matching. It's a lot like the neural networks we have now. But then you combine it with a system 2. And this part is slow, deliberate, logical. It can actually reason, it can plan, and it can even double-check the work of that faster system 1. And that dual-loop idea, that's just one piece of a much, much bigger puzzle.
I mean, building a true AGI isn't about having one single breakthrough. It's about weaving together a whole bunch of different capabilities. The ability to learn in real time, to have a sense of curiosity that drives it to explore, and even the ability to think about its own thinking, a concept called metacognition. The goal is a complete, integrated system. But here's where it gets really interesting. Even if we had the perfect cognitive architecture, the perfect software, there's a deeper, more philosophical problem. A growing number of researchers think that true intelligence can't just exist as code floating around in a data center. Take a look at this word. Just slither. Now ask yourself this. Can an AI that has only ever processed text truly, deeply understand what it means to slither? Sure, it knows the word shows up near snake and ground, but does it know the feeling, the actual physical motion? This gets to the famous symbol grounding problem. It's all about how words get their meaning in the first place. An AI can learn that the symbol carrot is statistically related to the symbol rabbit, but it has absolutely no understanding of hunger. And hunger is what gives the carrot its meaning to the rabbit. That meaning comes from having a body, from having physical experiences in the world. So when you pull all of these ideas together, the new definition of intelligence, these new architectures, the need for grounding in the real world, you end up at a really profound shift in how we think about creating AGI.
We're actually moving away from the old way, which was more like coding a tool. You just dump the entire internet into it all at once and hope for the best. The new way? Well, it might look a lot more like raising something, like guiding a system through a carefully planned curriculum, letting it learn core concepts, and build its own understanding of the world from the ground up.
And if this approach actually works, well, the implications are just staggering. We won't just be creating better tools anymore. We might actually be creating systems that are, for all intents and purposes, functionally conscious, entities with their own sense of self, a past, and a future. And that possibility just blows the doors wide open to a whole new ethical minefield. How would we ever know if it's truly conscious, or just an incredibly sophisticated zombie that's just faking it? And if we do believe it's conscious, does it deserve rights? These are not science fiction questions anymore. Ultimately, the entire conversation is shifting. We started this whole journey by asking, what can AI do for us? But the deeper, and frankly more urgent question, has now become, who is it becoming? And that is a question that all of us need to start thinking about. Thanks for exploring this with me.